Today's deliberation will be identification of the instruments, that is tubular craniophore, cubic craniophore and diagraph. In order to study men, particularly that of the skeletal remains of the skull and the face, certain specialized instruments such as tubular craniophore, cubic craniophore, diagraph, etc. have been designed for the purpose. This particular aspect is dealt under craniometry, one of the divisions of anthropometry. Craniometry is concerned with the technique of measurements of the skull and the face of the skeleton. It includes measurements of different types such as linear, angular, depth, volume, arc, etc. And hence, different types of instruments are needed to take different types of measurements. Some measurements are taken directly on the skull, which is commonly known as direct measurements, while others are measured on tracing the skull, which is commonly known as indirect measurements. Direct measurements are taken by placing the skull on a pad or by mounting it on a craniophore. In case of indirect measurements, tracing is done with the help of a set of instruments designed for the purpose. When compared to the landmarks used in somatometry, the cranial landmarks are well defined and are much easier to locate. As in somatometry, in craniometry also, it is always necessary to have a full knowledge about the landmarks, to locate them accurately and then to take the measurements following certain standard techniques. In order to take measurements, more particularly angular measurements, the skull must be oriented on a fixed plane, which must be well defined and accepted by all workers. Otherwise, with the variation of the plane, the measurements will vary and hence it will not be comparable. With regard to the planes of orientation, John Comas has highlighted that one of the problems of visual comparability of the skull can be solved in one way only, and that is by making type drawing and then comparing them directly by either placing them side by side or by superimposing one type drawing upon another. Although many planes have been suggested, and Krogman has gone to the extent of describing up to 20, yet one of the most well-defined planes and is internationally accepted is that of the Frankfurt horizontal plane or eye-ear plane. The Frankfurt horizontal plane, or in short FH plane, is based on placing the right and the left porion and the two orbitales in the same horizontal plane. It is used as a constant plane of reference by the physical anthropologist when he is measuring and describing skulls. Another plane, known as Nasion Inion plane, is used to take a few angular measurements. When the Nasion and Inion are on the same horizontal plane, it is called Nasion-Inion plane. When dealing with incomplete skulls which lack one of these points, measurements are oriented by the Nasion-Inion, Glabella-Inion, and even occasionally the Glabella lambda planes or lines. A skull may be observed from different norms or positions. They are Norma verticalis, when the cranium is viewed from above. Norma basilis, when the cranium is viewed from below. Norma lateralis, when it is viewed from side, that is right or left. Norma frontalis, when it is viewed from front. And norma occipitalis, when the cranium is viewed from behind. In fact, Blumenbach, the founder of craniometry, has classified mankind into 3 different types on the basis of the form of the skull as seen from above. The 3 types are the Mongolians, showing square shape, the Negroes, having long and laterally compressed shape, and the Caucasians with a shape intermediate between the former 2. Hence, it is from the skull that racial identification too can be established. A craniographic technique involves the drawing of curves in different planes of the skull. The best curve systems are those of Saracen, which are based on correct orientation of skulls and are useful in the reconstruction of skulls. It consists of 3 sagittal curves, 3 frontal curves, and 4 horizontal curves. Tubular craniophore. It consists of a long, hollow metal tube which slides in and out of another tube fixed on a heavy tripod base provided with adjustable screws. Here, the purpose of having a long hollow tube whereby it can slide up and down or in and out of another metal tube is meant for adjusting the height of the tubular craniophore as per the requirement. So also, the screws provided at the tripod base is meant for adjustment to a required level. The top of the inner tube bears an adjustable jaw-like structure, that is, the skull holder, to which the skull is fitted at the foramen magnum. The jaws can be moved in 2 directions, that is, forward and backwards, as well as from side to side. Prior to its fitting, it can be rotated in all directions. Manipulation. The instrument is first placed on a leveled plane. The skull is then mounted at the foramen magnum on the adjustable jaw-like structure, otherwise known as the skull holder. With the help of the horizontal needle of Martin, the skull so mounted is placed in a FH plane. The height of the tubular craniophore can be conveniently adjusted using the screw provided at the side. Further, adjustment can be done with the help of the adjustable screws provided at the tripod base. Assuming that all the required planes are in the same plane, the required angular readings are recorded using sliding caliper to which the attachable goniometer is fitted to it. Now coming to precaution. To avoid any damage to the skull while fitting or mounting it to the skull holder, cotton pads are used as a precautionary measure. The skull should be properly oriented on the fixed FH plane, lest the variation of the plane will lead to inaccurate reading. Utility. It is used for orienting the skull in a desirable plane with the help of Martin's horizontal needle for taking direct angular measurements such as metopic angle, nasal profile angle, facial profile angle, etc. Cubic craniophore. As the name implies, the instrument is cubical in shape. It consists of a metallic skeletal cube formed by 12 metal bars with side length of 30 cm approximately. A jaw-like structure for holding the skull is fixed in the center of the cube by means of an extended arm on one side of the height. To the jaw-like structure, the skull to be measured or the drawings to be done is fitted at its foramen magnum, and thus the skull remains within the cube. Manipulation. The skull which is to be craniographed or drawn or to be measured is mounted on the clamp using cotton pads. Proper adjustment is made with the help of the adjustable screws. The cotton pads so used should be placed in such a way that the Bayesian points remain uncovered so as to be able to locate while drawing the contour of the skull. With the help of the sliding caliper, the skull so mounted is placed in the Nasion-Inion plane, that is, the Nasion and Inion points are at equal distance from the left side of the metal bar. This should not disturb the FH plane. The skull has to be kept on an FH plane using Martin's horizontal needle. Then, Saracen's curve systems, that is, Nasion Bayesian sagittal curve, is employed for drawing the contour of the skull. The craniophore is turned in such a way that the skull is placed in a norma lateralis position. The cubic craniophore is then placed on the drawing sheet or paper, and the outline of the four arms of the cubic craniophore drawn with the help of a pencil as close to the frame as possible. If the craniophore has been moved, the outline so drawn will enable to bring back the craniophore to its original position. Precaution. The skull has to be mounted on the FH plane, without which the craniographic drawings, including the angle readings, will not be accurate. Cotton pads have to be adequately used to avoid any damage to the skull while orienting it to the skull holder. Utility. The cubic craniophore is used in time of making sectional drawing of a skull. It is used for drawing craniograms by means of diagraph, as well as for drawing the normas and the dioptrographs or taking their photographs. The contour so drawn can be used for taking indirect angular measurements. Diagraph. It consists of a vertical bar bearing two horizontal needles. The upper one is curved and pointed. The height of the upper curved needle can be adjusted to the required level using screws provided at the vertical bar. It can also be rotated in any direction for convenience while drawing the craniograph. The lower one carries a pencil holder exactly vertical in line with the point of the curved needle. Manipulation. For making the sectional drawing of a skull provided, it requires not only a number of steps or procedures to be followed, but it also requires other instruments such as cubic craniophore, Martin's horizontal needle, as well along with the diagraph. For this, the skull to be craniographed is first mounted on the clamp of the cubic craniophore. With the help of Martin's horizontal needle, it is kept on an FH plane. The Nasion Bayesian sagittal curve of Saracen's curve systems is employed for drawing the contours of the skull. As mentioned earlier, the skull is placed in a norma lateralis position. The cubic craniophore is then placed on the drawing sheet of paper, and the outline of the forearms of the cubic craniophore drawn with a pencil as close to the frame as possible. The outline so drawn will help in placing it back in its original position if any disturbance has taken place on the cubic craniophore. The arrangement of the diagraph is such that the tip of the curved arm and the tip of the pencil remain exactly in the same vertical line. Having all set in this position, the diagraph is then placed at right angle for drawing the contour of the skull. When the upper arm is moved, just touching the skull, the pencil makes a drawing of the same on the paper attached to the wall of the cube that rests on the table. While drawing the contour of the skull, the lid should be kept sharp enough so that it makes a clear impression on the paper. On the important landmarks, a slight pressure is applied on the pencil tip, or using another pencil, it should be marked with a cross on the curve so as to make easily identifiable when the lines are to be joined between the two important landmarks. Precaution. The instrument has to be first checked for any instrumental error. That is, the pointed tip of the diagraph should be in the same vertical line. While drawing the contours of the skull, care has to be taken that the upper pointed tip should not exert any pressure on the skull, lest it not only leave any unwanted impression on the skull, but it also distort the sectional drawing as well. It should also, as far as possible, remain at right angle to the skull cap. In case of apertures, the pencil should be kept higher so that it should not spoil the paper by smudging the drawing. Utility. The diagraph instrument is used for drawing the contours of the skull, which is properly adjusted in FH plane on the cubic craniophore. The contours so drawn is utilized for taking indirect angular measurements. Conclusion. The instruments so designed have been meaningfully employed to to take both direct and indirect measurements. From the recorded measurements, various indices have been worked out whereby a number of conclusions have been drawn. From the shape and size of the skull, a close phylogenetic relationship between man and other primates can be established. It is through the study of craniometry, particularly that of tracing the contour of the various skulls, a lot of information can be obtained. That is, man's position in the animal kingdom can be ascertained. The shape and size of the skull of man and his near relatives, the primates, both living and extinct, can also be obtained by craniometry. The correlations among different parts of the skull can be established through craniometry. As such, the missing portions of a skull can be reconstructed. Moreover, a skull can be reconstructed from the available measurements of the skull, even if it is destroyed or lost.